All right, well, I've realized I know what I'm going to do, and I just want to tell you now, if you want, you can show up. If you tune in on Wednesday, I have in my Hacking Mobile Devices class, I've got one of the open rooms, open days I leave for extra things. And what I'm going to do here is have some extra credit projects about the risks of AI, including Copilot and machine learning models and large language models. I just wrote 3 new projects for that. So I'll demonstrate them here and anybody can attend that. I'll put a note at the top of my page. So tune in Wednesday if you want to do that for extra credit. Anyway, back to the malware analysis stuff we're doing today. There we go. Well, all right, whenever my machine responds, it's doing this slow thing again, which it does frequently when I'm broadcasting. Probably means there's a process somewhere I could quit that would save some CPU, but we can probably get through the day this way. Okay, so services run in the background without user input. Let's see if I can get it to stay on that page. All right, and so they provide some kind of service for the like application identity or something, Windows Audio, the browser, which is not a web browser, it's something that browses your local area network to find information about shared files. All these things are running in the background, and most of them run before you log in. But you can define your own, and malware often does. All right. The system account I mentioned before is what most things run as that run before you log in, because the operating system doesn't know. Oh, I wonder if my internet is not working. I see my vision. Yeah, my sound is cutting in and out. Yeah, it looks like something's wrong here. Okay. Let's see if it's going to get better. I feel like it just did get better. Yep, stopped happening. Yep, I think something happened on my machine. It decided to do something stupid instead of the right thing, and now it's moving again. All right. So services launch automatically. Windows start typically as system. Now it's not responding to me again. Okay, so this is the API call to get to the Service Control Manager. You can create a service here, and you can specify a lot of parameters like whether it starts at boot time or delayed or only when necessary. And you can start it manually if you want to with Start Service. And all right, this the most common type of service is a Win32 share process. So if you look in Process Explorer, you'll see an SVC host executable that is hosting a whole bunch of services. I think I got a picture of that here. Yeah, so here is all these SVC host things are running, and if you hover over one of them, it'll show you this one is running about 10 services on the same executable. That's how they get launched. They specify that in the registry. All right, you can also have ones that run as an exe in a separate process, or ones that load into the kernel, so they have direct access to the hardware. All right, and these are defined in the registry. You define the start value, which is down here. This start is 3, and 3 is for load on demand. There are other choices, so these are all the parameters for services. All right, you can do it all with a command line, SC command. So SC will query about the browser. This will give me all the settings, and you see all the various parameters of a service. All right, the component object model is another way for code to be running that is shared by several programs. And so if you want to use a component object model, you have to call OLE initialize for objects linking and embedding, and then co-initialize before you call the libraries. And they're accessed by globally unique identifiers, which are long, random-looking hexadecimal numbers, class identifiers, or interface identifiers. They amount to about the same thing as services, but Microsoft handles and for some reason has a different sort of object available. Then there's exceptions. If you divide by 0 or you try to access memory that is not available to your process, you'll get an exception. So it then goes to an exception handler. Something bad has happened, so I cannot continue to execute the code in the order the developer intended. So it now goes to the structured exception handler. which lists various types of exceptions and what code to run when that exception happens. And if your developer included exception handling in their code, then it will find an address in the structured exception handler that points to code that handles the exception gracefully by popping up a box or trying again or whatever the developer wanted. If it doesn't find an exception handler that can handle this exception, then the program crashes and it pops up a generic Windows message like your program has stopped. So here's storing the exception handler information, pushing it into this location. It's one way to load it in assembly code. All right, and then there's kernel versus user mode, as I mentioned before. The hardware contains 4 rings, the kernel mode with all privileges to execute all machine language commands, and various other levels with less privileges. But no modern operating system uses ring 1 or 2. All they do is they use ring 0 and ring 3. So everything the user launches is in lowest privilege in ring 3, and ring 0 is kernel mode, where it has complete control of the hardware. So, let's see if this is, it jumped. All right. So, everything the developer writes runs in user mode except the operating system and hardware drivers. You can't access the hardware directly, so you can only get there through the API. So your user mode process has its own memory, security provisions, and resources, and the point of this is if your user land code crashes, it can pop up a box and say your program has stopped, so would you like to relaunch it or what? But the whole operating system does not crash because the kernel is still running. That's the idea. It's like a safe place for your code to run. So you can have something like a restore. If you have Microsoft Word, for example, and it crashes, it will pop up a box saying, Word has crashed. Would you like to try to recover your document? And it will try, and usually it can recover your document because the operating system is still there. If you call the kernel, you can't jump into the kernel. What you do is you call one of these functions, sysenter, syscall, or int2e, all of which do the same thing. They're just different versions of it. And these use tables to find kernel functions and jump to them. So all the kernel processes share resources. They are not isolated from each other, so it's pretty dangerous. That's why there's a blue screen of death. I went around all the conferences demonstrating a while ago. I could crash the machine with some IPv6 packets because it would exhaust too many kernel resources, and the kernel doesn't have the memory management that userland does. If the kernel does crash, you get the blue screen of death and everything is over. You have to restart the machine. And antivirus software and firewalls run in kernel mode, and so do device drivers. So if you get your malware into the kernel, that's more powerful than malware running in userland. And therefore, kernel mode rootkits were very common. I don't know if they're that common anymore. They're much harder to write since Windows Vista. Most malware doesn't run in the kernel, I think, especially nowadays because Microsoft keeps implementing more and more kernel defenses because they got tired of malware running in the kernel. Then there's the native API. What this is the low-level functions that are only intended for internal Microsoft use, but you can read the code easily in the Microsoft Windows kernel and the API and just see what it does by reading the assembly code, so they can't keep it secret. So people use the native API. So here's what you're supposed to do. Here's what a normal developer will do. They want to call something like print something on the screen. They load kernel32.dil. Remember the general rule for Microsoft, everything is named the opposite of what it is. So kernel32 is not the kernel, and it does not run in kernel mode. It is the user mode function intended to make it possible for your programs to call the kernel. They will then call the native API, ntdil, on your behalf, and that will go across the border and talk to NTOS kernel. This is the kernel, NTOS kernel.exe, and it will then manipulate data structures down here that affect your hardware. So this is the normal flow. A normal user would only use kernel32. They would not use ntdil directly because these functions are poorly documented and sort of harder to use, but they're more powerful, and that's called the native API. So it's undocumented, and you can use it to sneak around malware detectors that might be looking for suspicious API calls and not. So your security program might just be looking for certain calls to kernel32. So if your application calls directly down to the native API, it might bypass your security program. right. I'm just looking. There used to be something that told me the quality of my network connection, and I feel like it's gone. All right, anyway. All right. I see it's got drop frame numbers, which is acceptable. All right, so here's some native API calls, query system information, query about a thread, a file, or a key. These sort of things are the low-level functions that provide more information. And NT continue returns from an exception. So these are common native API calls you'd find in malware that you're very unlikely to find in normal commercial software. All right, let's try another Kahoot. Should be here. All right. Somebody's working on Velociraptor, I see. Anyway. All right, let's give it a shot. All right, the user account more powerful than the administrator. All right, that's system, good. Root is Unix, not Windows. All right. What service loads in ring 0? Kernel drivers. Those are in the kernel. As you'd imagine, they have to be. They have to touch the hardware directly. All right, where's the native API? All right, ntdil is the native API. All right, and if you divide by 0, what happens? All right, you go to the structured exception handler because that will cause an exception. All right. All right.